Welcome. Dzień dobry, Poznań. I would like to introduce myself. My name is Krzysztof Szafranek, and this is for all three of you who don't speak Polish. This is a phonetic version of it. Currently, I'm working as HTML5 game developer at Huga. Before, I was working for Nokia as a front-end architect, developer, and before at a company called Roche, also as a front-end guy. So for the last 10 years, I was doing mostly front-end development. Today, I would like to talk about unit testing. I wanted to put a Wikipedia definition of what is unit testing, but it was way too much text, and I was told that nobody will even bother to read it. So instead, I created a shorter definition, which is much more practical, and it applies to JavaScript. Unit test, if you simplify it in the most possible way, it's really a function that is testing another function. And I think unit testing is something that is very similar to physical exercise, for instance, running. So most of the people who are doing programming already know what is unit testing, and they also know that it's very good for you. That, yes, I should do unit testing. But just like with physical exercise, pretty much everybody knows it's good, but only few people are actually doing this. Recently, in October, I made a short poll on my personal blog, and I asked people whether they are doing unit testing, whether they know what is unit testing, and I also asked about other good programming practices in JavaScript. And here are the results of this poll. So it turned out that pretty much everybody knows what are unit tests. Only 3% of the people didn't know that. There is a small group which I would ignore because this includes only superhumans that don't need unit testing because they write code without any bugs whatsoever. So I'm not going to talk about this group today. However, there is this huge portion of people who realize that unit testing is good and they would like to write it, but they are not doing this. So I would like to have some useful advice for these people in the next part of this presentation. And the last group, and to be honest, I was actually quite surprised how big it is. These are the people who are writing unit tests. Some of them are doing this only from time to time, so not for every functionality they create in their code. And about half of this group is writing unit tests on a regular basis as a normal part of their workflow. Also, I have some advice for these people. I'm very interested in this room. How many of you are writing unit tests? Okay, so I hope that I will have something useful for both of you who raised their hands and the ones that didn't yet write unit tests. So why we should write unit tests? I think there are several benefits. One of them, and probably the biggest one, is that they increase your confidence in the code. So for instance, if you write some functionality and then you would like to change it, you don't really know if you have a lot of code, whether you didn't break some other part of the code you forgot to test. And if you have unit testing, if you have unit tests in place, you are very much likely to be told automatically, straight in your face, that something breaks, and this way you are confident to make a change, because unit tests will tell you that things have changed and you have to update your code. So you are much more confident when you have to create a new change in your code base. And this is also very important. I think unit tests encourage good design. Some people like to create huge diagrams and think a lot about architecture. Personally, in front-end projects, I'm not such a huge fan of it. I rather believe that if you start from basics, like writing proper functions, avoiding duplicated code, if you write a code that is easily testable, you are much more likely to end up with good design rather than you start with paper and UML diagrams. And with unit testing, if you start using it from the beginning, you are much more likely to create a code that is very easy to read, very easy to understand, and easy to verify. This is something that is not another form of communism. It means that people in the code, in the whole team, co-own the whole code base. For instance, if I wrote some piece of functionality and you would like to change it, thanks to collective ownership and unit testing, you are free to do it without asking me for permission, because unit tests will tell you if some stuff breaks. So this allows much easier code ownership. So if tomorrow I will be hit by the bus, hopefully not, but you never know in Poland, you are still able to modify the rest of the functionality because unit test will notify you if you broke something or not. So you are much more confident. And big advantage for us, for front-end people, is that with unit testing, we are also allowed to test our code in all different browsers at the same time with no or very little effort. Later on, I will show in practice how it looks like, but there are frameworks that allow you to run your tests at the same time in different browsers and make it in a fashion that is very easy to automate. So just with one click or one shell command, you could run all your tests in all different browsers you have to support. However, as I mentioned before, people avoid writing unit tests for different reasons. And probably the primary reason, at least from the people I have talked to, is that we don't have time for that. So yes, tests are good, but we have a deadline. We don't really have a time for that. And it could be a very valid argument. There is a chart that I shamelessly stolen from this person. As you could see, he's totally building trust. His name is Martin Fowler. He's known for his work for agile and design patterns. He came up a few months ago on his blog with this chart that is showing a value of good design and also unit testing. So there is a period in the project timeline in the beginning. Oh, excuse me. In the beginning of a project here, where if you don't really pay attention to unit testing, good practices, good design, you're actually going faster. So this blue line is showing you that you could have more features comparing to the situation when you spend extra time on unit testing. However, with great power comes great responsibility. And very quickly you realize that you reach this point where the code is getting more and more ugly, more difficult to understand, and more difficult to modify. So you end up in a situation that you still have to add new features to the code, but because of the bad design, lack of tests, you cannot move forward as quickly as you would like to. So eventually, there is a huge benefit from having good design and code coverage. Eventually, you could move faster. The problem is to establish where exactly is this point. So should I bother with unit tests or not? And from my experience and also from what Martin Fowler says, usually this point in time happens in weeks, within weeks, and not in months. And people very often have a tendency to underestimate. So they think, well, let's do this quick hack together, and it will somehow work. But after a few weeks, they realize that they are actually moving forward much slower than they should be. So if you are working on a project that involves few people, by few, I mean more than one person. And if this project is going to last for more than a few weeks, I strongly encourage you to write unit tests. So let's come to the part where I explain how to start with unit testing and how you could actually do it. Unit testing and writing tests is actually very easy. There is an acronym called TDD. It stands for test-driven development, which comes down to this. First, you write a test. Secondly, you write a minimum amount of code that is satisfying the test, which means that the code that you have to write is making the test function pass. And if that works, if your test pass, then you could refactor. And then rinse and repeat, rinse and repeat. Some people prefer to do it slightly in a different way, so they first write the code and secondly write the test. I'm not saying that it's worse or better, just do what you prefer. This approach, however, is forcing you to think about design of your functionality, about your code first. So there are strong benefits of having your tests written first. What are the tools that you could use to write unit tests and run them when you are using JavaScript? There is one tool that I'm a huge fan of since a few weeks. The last week I spent using it very heavily. To be perfectly honest with you, it's still in beta version, so there will be dragons. There could be some issues, but so far for me, in the project I'm working on at Ługa, it turned out to be pretty good and pretty solid. This is something that is not only a test framework, but also a test runner. What's the difference between test framework and test runner? So test framework is a library that is allowing you to write assertions, so things that tell you whether some functionality is true or not, whether some function returns true or false, whether something is a string, this kind of statements or assertions. And test runner, as the name implies, is a program that allows you to run your tests in automated fashion. And this is quite a unique feature of Buster.js, because most of the unit testing framework are doing just the first part. So they are providing a JavaScript library that allows you to write assertions and write test code. However, with Buster, you could run your tests also in Node.js and in the browser. Some of you maybe have heard before about a framework called JS Test Driver, which is a bit similar to that. The advantage of Buster.js is it does pretty much everything with JS Test Driver, plus it's written in Node.js. So it has 100% more shiny comparing to JS Test Driver. And it's faster. How does JS Test Driver and Buster.js work? How do they work? So the idea is explained on this picture. Here you could see that you have to load using your configuration files your sources, and sources include both functionality in your code and tests for this code. Then a client, which is a command line utility, I will show it later, runs a code, it sends it to the server, and then the server runs it in your environment. It could be a browser, but it could be also Node.js. So if you have something on the backend side with Node, you could use Buster instead of the browsers here. One of the coolest features of Buster that I really, really like is demonstrated here. If you have asynchronous testing, and I think Mariusz will have a talk about this soon after my talk. If you have asynchronous testing, sometimes it's very difficult with regular JavaScript frameworks to test. However, Buster allows you to move forward in time using something called tick. For instance, the first function here is your regular code that you would like to test. This is a function that does something in the future in 100 milliseconds. So here it is just setting a global variable on window object. It sets it to true. Normally, you would need to wait 100 milliseconds for this function to complete. If you have 100 such functions, eventually your code will run slowly. And you don't want your tests to run slowly. You want your tests to be executed in something like 1 second or less. So with Buster.js, you could tell Buster to move forward in time here by 200 milliseconds, and it doesn't take 200 milliseconds. It happens instantly. So this way, you are working with your code like it's synchronous. It happens instantly, but by overwriting setTimeout method from the browser, it happens immediately instead of having to wait. And as far as I know, this is a unique feature of Buster.js. If you are writing a lot of code that is involving animations or other asynchronous functionality using setTimeout, this is something I really recommend to use. If you are not, for some reason, fan of Buster.js, you have plenty of other tools. But yesterday I was told that I should actually remove this slide because it will just confuse people. So let's skip this slide. And my general advice is that if you are totally new to JavaScript testing, I would recommend Buster, even though it's still quite new. But if you already are using some other tool and you are happy with it, just feel free to use it. It's more important to actually write tests rather than spending a lot of time searching for a perfect tool. And now it's the most tricky part of every presentation. I would like to show you in practice how you could do some simple unit testing using the approach I demonstrated before. Let me switch to code. It just happens that I have my tests already written. So here I have a test using regular Buster.js syntax. Here it creates a test case. As you could see in Buster.js, you could create very descriptive names for your test functionality. So you could even use strings to describe what your test is actually doing. And I would like to write a function that will create a meta element in the head of document. And this is something that is created for mobile devices, and I want to create a meta viewport, which, as some of you may know, is something that you could use on touch devices to control whether things could be zoomed in or not. So I'm writing a test that is looking for meta element with the name viewport. And with Buster, I could tell it to confirm that this element doesn't exist. There is a word called, or assertion called refute that says that this element will be falsy. So it could be null, it could be false, it doesn't exist. Then I'm running my magic function. It's called create meta viewport. And this function will actually create this element. So after this, I have to run the query again, because with DOM operations, you have to refresh it. You have to ask for this element again. And then I'm checking if this element now exists. So first, I'm checking, please confirm this element doesn't exist. Then I'm supposed to create it. And then I'm supposed to get this element. How the code for this function looks like. It also accidentally happened that I have this code already written. So I'm using standard DOM operations, nothing like jQuery. I just use create element, meta, then I'm setting two attributes. The first is the name, the second one is content, and this is the magic string you have to paste if you want to disable zooming in your mobile version of a page. And then I'm just appending this element to the head of your document. So assuming I have my test, I have my source code, let's run the tests. And I'm going to use Buster.js for that. I mentioned before on one of the slides that first you have to run your server. And there is a command for that called Buster server. Let me run it. As you could see now, the server is running on localhost on this port. And I have to connect browsers that will execute the tests. I'm a huge fan of Firefox, and I'm using Nightly. So let me go in Nightly to this URL, 111. And you could see that Buster.js is responding, and it allows me to capture the browser. But because I want to do some functionality for mobile devices, it happens that I also have iOS simulator, which is looking like this. This is standard part of Xcode. So if you're using Mac, you'll get this. And let's capture this. Because of the low resolution, we cannot see the full screen. But you could see that Firefox, which I connected before, is already here. And I could add this browser as well. So now I have two browsers connected. The next step I have to do is to actually run my tests. Let me go back to terminal. In a different tab, I have to run my tests. And the command for that is buster test. Let's see what happens. Imagine that my test pass. If everything is green in most of the frameworks, it means that everything is fine, your tests are passing. However, I mentioned that the process is usually you first write minimum working implementation, and then you could improve it. And your tests allow you to fix and discover any mistakes you make in the process. Now is the tricky part, because I'm going to actually write code right now, live. I hope that God will take care of me or someone else. So as you could see, this code is quite verbose. DOM API is very verbose. So there is an easier way to do it, even without jQuery, because you could just use inner HTML. So maybe just to make it a bit easier, I will keep the old code so far, and I will use inner HTML, which allow me to make it much shorter. So my meta element will now be meta name viewport, and content will be exactly the same as it was before. So I could copy this from this old thing. And now I have to append it to head. Head inner HTML meta. Okay, so let me run the tests again. Excuse me? Oh, so okay, but let's read what my report is saying, because apparently, as you could see by the red color, things are not working. And just like a colleague said, we don't have head element. So let me get head. And because I'm lazy, I will just copy this from before, and let's run it again. Oops, and there is still something wrong. But please notice that I didn't have to go to the browser to actually see it, because the browsers are already connected. So now I get all the feedback here. And what happens, it seems that the element I expect to be true is falsy. So let's see what happens here. Do you have any idea what's wrong?
Yeah, you're missing the bracket at the end of the meta.
Here. Mm-hmm. OK, let's give it a try. Let me clear the output from the previous run. It seems to work. Thank you, Rafał. So this way, I demonstrated to you that you could get a feedback very, very quickly, and without having to run the tests manually in different browsers. You could get this automatically in a very, very easy fashion. So let me repeat. First, you could write the tests, or if you prefer, you could first write your code, then write minimum implementation that works, and then when you are confident, thanks to the test, that it works, you could move on with refactoring. And here I show you that if you refactor, tests will allow you to discover mistakes very quickly without having to deploy the application somewhere, without having to run it in different environments. And then you could repeat the process with another function. I mentioned that it's going to be a practical guide to unit testing. So if somebody has already experience with unit tests, I have some things I learned myself, sometimes the hard way, and I would like to share these learnings from you. First, you shouldn't really test things like getters and setters. Just test things that matter, so functions that are actually doing something. I'm not a huge fan of struggling for 100% code coverage, which means that every line of your code is covered with tests. Test things that matter. You shouldn't also test network connections or external dependencies. You should test your own code. For instance, if you have a code that is issuing AJAX requests, you could easily mock it, which means create an object that is pretending to be a server that is responding to your calls instead of sending real requests, because otherwise you are making another dependency on network. So you are not really sure whether network cable is disconnected or your code is wrong. Test only your own functionality. And actually, Buster.js is allowing you to make it very easy. It allows you to mock the server functionality. Keep your tests fast. By this, I mean keep it running in under 1 or 2 seconds. You don't want to have set timeouts or things like this. Use tick functionality and make them run really, really fast. Sometimes, I think most of you will have the situation that you face a project that is huge and doesn't have any unit tests. I'm not encouraging you to go back in time and trying to write tests for all functionality, but if you have to fix a bug, write a test for it first. If you have to add a new feature, start writing tests. You don't have to go back and fix old stuff, but everything new that you create should be already covered with tests. This is very important. Because Buster.js is working from command line, it's very easy to automate. And if you are running some continuous integration system that is running tests on the backend side, it's a great idea to also add your tests for frontend to your continuous integration setup. It means that you will get feedback from automated system every time you commit code to code repository. You don't have to do it manually. And also, if your colleagues are a bit shy and don't want to write unit tests but would like to change it, then you could make sure that during code review, and I hope you are doing code reviews, tests are part of it. So expect tests to be delivered together with actual code. Now I would like to present you with a challenge. So when you go back to work on Monday, or maybe even go back home today or tomorrow, depending on the party, and would like to write some code, I challenge you to write some unit tests together with your actual code. If you have questions and you would like to ask them to me, feel free to contact me. This is my name, this time without phonetic pronunciation. You could find my email here, my Twitter here, and my website here. So thank you very much. Do you have any questions? We have cups as far as I know.
Okay, so we have some time, so there will be more space for we can ask more than one question. So, who has first one? Just raise your hand. I see there. Okay.
My question relates to mocking. I was going to ask about this mocking the server functionality, which you mentioned already. So I think the Ajax mocking is in place in Buster, but what are the other mocking facilities in Buster? Like, can you mock DOM, for example, to make it faster? And
there is no built-in functionality, but sometimes you could just create your own object. Buster is using a library called Sign-On, which could be used with any unit testing framework. So if you're using just Mean, for instance, or something else, you could use Sign-On, and it allows creating mocks very easily, pretty much for every framework.
And the second thing is, can you use some templates which you would like to work on? Like if you have a functionality which is strictly client-side, like widget, which do something on interactions. So can you use some base templates, load them, and something like setup and reset after the tests? So you reuse these templates.
That's an excellent question. So the framework I mentioned in my presentation briefly, called JS Test Driver, has exactly this kind of functionality. So it allows you to just write HTML without any escaping or anything like that in comments, and then it will parse it and add it to DOM. So if you have to bootstrap your DOM structure, create a template, JS Test Driver is actually a better solution because it does it. I'm pretty sure that Buster will have it eventually, but because it's still beta, it doesn't have this functionality yet. So you have to use, like I did, inner HTML to create it, or DOM operations.
All right, okay, thanks.
Any other questions?
I have a question about automatically running tests. For example, if we are using Git repository, how to run a test when we are pushing code to repository?
Yes, so Git has something called hooks, and these are little scripts that are run in different situations. So there is a special hook for commit, special hook for pull, push operations. You will find it in your Git repository in a folder called hooks, and these are just shell scripts. So you could select, for instance, a script that is executed upon pushing a new change to Git repository and add your functionality there. And it will be executed whenever any person in the team pushes the code to your Git repository. So hooks is the word you would like to Google. All right, and when unit tests return error, can we stop pushing or commit the code? Yes. All right. I'm not sure. All right. All right, thank you. I'm not sure. I haven't tried this. So in this situation, what I would recommend, the code shouldn't be deployed, but I think it will be pushed. All right. So you shouldn't deploy it on production or staging or test server, but probably it will end up in repository. Thank you very much.